Hello, Hornets, and thank you for joining me today. Today we are continuing to work with solving trigonometric functions. Now, for my students, I gave some practice for them to do, and I'm going to be going through and working on the even problems as I've asked them to do the odd problems. This has two sides to it. On the first side, we are looking at only a single expression. So it's pretty straightforward, and we're working from 0 to 2 pi in radian mode. I'm expecting exact values, so please be aware of that. On the second side, once again, we are continuing with radian mode, but now we are looking at quadratic form of our trigonometric functions. Now, please be aware, I'm going to do the entire first page of the evens, but I will not be doing the entire second page of evens. This is merely a matter of time and exhaustion on my part, so I'm hoping that this will help you enough, and then you can continue on to the second page. So let's go ahead and begin. First of all, recognize the domain is in radians, and we are going from 0 to 2 pi. We cannot accept 2 pi, but we do accept 0 pi. Now, when we're doing this, our goal is to try to get rid of any coefficient that is in front of the operation. To do this, we are going to multiply by the reciprocal, and when we do, we end up getting negative root 2 equals the cosecant of theta. Now, in order to do any of these, you have to know your ratios before you even begin. So if you have not yet learned all of your ratios and know them off the top of your head, this is going to be very hard, and everything that I'm doing is not going to make as much sense. And I would recommend you go back, study your ratios, and learn them before you attempt to do this. If, however, you are not willing to learn them, there's not much I'm going to be able to do. And I'm just talking to the wall. So please, you have to do something. I cannot do it all for you. All right. So when we're talking about the cosecant, we're talking about the reciprocal of sine, and sine is going to be negative in the third and the fourth quadrant. The reciprocal of root 2 is root 2 over 2, and as a result, we know that sine is root 2 over 2 with a reference angle of pi over 4. Therefore, the cosecant will be negative root 2 at 5 pi over 4 and 7 pi over 4. Once again, that's the third and the fourth quadrant. Number 4, I'm going to subtract, and I'm going to end up getting negative 1 equals the secant of theta. This is the same thing as cosine equaling negative 1, and there is only one value where this occurs. That occurs on the ordinate or the x-axis, and it is the negative x-axis right here, and this is pi. So my answer to number 4 is pi. Going to number 6, I'm going to multiply both sides by negative 2, and I end up with negative root 3 over 2 equaling the sine of theta. Once again, we are in the third and the fourth quadrant. The reference angle for a root 3 over 2 in the first quadrant is going to be our pi over 3. So in the third quadrant, we're looking at 4 pi over 3, and in the fourth quadrant, we're looking at 5 pi over 3. Moving on to number 8. I'm going to go ahead and I'm going to add 5 to both sides, and I end up with the cotangent of theta, and that cotangent of theta is equal to negative 1. Now we know that the tangent of negative 1 happens when the sine and the cosine are opposite. This occurs in quadrant 2 and quadrant 4. So we're looking for the opposites of sine and cosine in the second quadrant. This is when cosine is negative root 2 over 2, and sine is positive root 2 over 2, and this is at 3 pi over 4. In the fourth quadrant, this occurs when the cosine is positive root 2 over 2, and the sine is negative root 2 over 2, and this occurs at 7 pi over 4. We then go to number 10. We divide both sides by negative 3, and we get the cotangent of theta equaling negative root 3 over 3. Cotangent is root 3 over 3 in the first quadrant at a pi over 3. So we're going to go ahead and we're going to work with, hang on a minute, pi over 3, yeah, that's correct. And therefore, in the the second and the fourth quadrant are what we're looking at. In the second quadrant, I'm looking at 2 pi over 3. And in the fourth quadrant, I'm looking at 5 pi over 3. All righty, continuing. We're now continuing with our tangent. Tangent of theta when we solve is equal to 0. Tangent is 0 at 0 pi, at 0 pi and pi. There we go. All righty, continuing. Cotangent is 0, and cotangent is 0 at pi over 2 and 3 pi over 2. Continuing with number 16, dividing both sides by -9. I end up with my tangent of theta, and I end up with -√3 over 3, and this is at the reference angle pi over 6. Tangent, just like cotangent, is negative in the second and the fourth quadrant, and as a result, I am looking at, once again, 5 pi over 6 in the second quadrant, and then 11 pi over 6 in the fourth quadrant. And that's my first side. Notice it goes very quickly when you know your ratios. You have to know the angle, you have to know the reference angle, you have to know the quadrants where they are positive and negative. Let's go ahead and now go to the second worksheet, or the second half of it, I should say. The second side, since I attempted to do it on double-sided and I failed miserably. All righty, so we're going to have to solve for our cosine, and in order to do this, I'm going to let cosine of theta equal u. This is my dummy variable. Once again, please take note, our domain is 0 to 2 pi in preparation for calculus next year. I'm also going to rearrange this. So I'm going to be adding 2 to both sides, and I'm going to move my 2 cosine to the front. So keep in mind that what we're talking about is 2 cosine theta, the quantity squared, minus our cosine of theta, and then we have this -1 equaling 0. When I put my u in, I get 2u squared minus u and -1 equaling 0. I'm now going to factor, and I end up with a 2u times u, and I know I have a 1 and a 1. I just have to make sure that I get a -1u when I multiply. That forces the negative here and a positive here, equaling 0. We're now going to take each piece and put back u. So I have 2u plus 1 equaling 0, and that's going to give me 2 cosine theta plus 1 equaling 0. When I solve, I get cosine of theta, and that's going to equal -1/2, and we know that that's a reference angle of pi over 3, and cosine is negative in the second and third quadrant. So in the second quadrant, I'm looking at 2 pi over 3, and in the third quadrant, I'm looking at 4 pi over 3. I then go to the next piece. This is u minus 1 equaling 0 for cosine of theta minus 1 equals 0, and therefore cosine of theta is trying to equal 1. We know that cosine of theta is going to be a positive 1 at 0 pi, and you'll notice I now have 3 solutions for number 2. Number 4, I'm going to do the same thing. So I'm going to let u equal the sine of theta, and I'm going to put that in as 2u squared plus 3u plus 1 equaling 0, and I'm going to factor 2u, u, 1, and 1 with a plus and a plus. I therefore have sine of u, and when I solve, I end up having -1/2. That's a pi over 6 reference angle in the third and fourth quadrant, and therefore I have 7 pi over 6 and 11 pi over 6. I then put u back, and I have sine of theta equaling plus 1 equaling 0, and therefore my sine of theta is equaling -1. Now our sine of theta is going to equal -1 on the ordinate axis. That's the negative y, and this occurs at 3 pi over 2. And here are those answers: 7 pi over 6, 11 pi over 6, and 3 pi over 2. This brings me to number 6. Now notice in number 6, I now have a situation where I have two different tangents. So I'm now going to just kind of simplify this a little bit. I want it to equal 0, so I have 0 equaling root 2 tangent of theta, sine of theta, and I have a minus tangent of theta. So I'm going to factor out the tangent of theta. So 0 is going to be the tangent of theta times root 2 sine of theta minus 1. We're now going to set each of them equal to 0. When is tangent of theta equal to 0? And when I solve, I'm going to have when is the sine of theta equaling to root 2 over 2. Now you'll notice I'm now about to get several answers because we know that tangent is 0 at 0 and 0 pi and 1 pi. We know that sine is root 2 over 2 at the reference angle of pi over 4, and it's positive in the first and second quadrant. That gives me the two answers, pi over 4 and 3 pi over 4. And there are my four answers, and I now go to number 8. Now in number 8, I'm going to be adding, let's go ahead and add 2 tangent squared theta, so that I end up having 0 equals tangent squared theta minus 2 tangent theta plus 1, and I'm going to let u equal tangent of theta. Once again, that's my dummy variable. So now when I put it together, I have 0 equals u squared minus 2u plus 1. And this is our doubling or our perfect squared identity, where we have u minus 1, the quantity squared. And when I put it back in, it just means I'm going to end up having a double root. But I still have tangent of theta when I put the u back in, and it's going to equal 1. We know this happens in the first quadrant, and it happens in the third quadrant when tangent is positive, and the reference angle is pi over 4. So my first answer is pi over 4, and my second answer is 5, pi over 4. And I now have number 8. This brings me to number 10. Once again, I'm going to make sure that I add the larger tangent that's negative to the other side, so that I end up with a positive tangent squared theta. I have minus 2 tangent theta, and I have a plus 1 equaling 0. Once again, I let u equal, the dummy variable, equal tangent of theta, and I'm now looking at u squared minus 2u plus 1 equaling 0, and that is once again u minus 1, the quantity squared equaling 0. When I put tangent in and solve, I end up with the tangent of theta equaling positive 1, and we know that that is once again in the first quadrant and the third quadrant, and we get our answers again, pi over 4 and 5 pi over 4. And we now have number 10 done. This brings me to number 12. Now, as we did before, notice I'm going to move this over. This is the negative 2 cosine squared theta, and I'm going to end up with a 4 cosine squared theta plus 4 cosine theta plus 1 equaling 0. I'm going to let the u equal cosine of theta, and I therefore have 4u squared plus 4u plus 1 equaling 0, and I'm going to now factor. This is once again a perfect square, so I have u squared plus 1, 2u plus 1, the quantity squared, and that's going to now give me cosine of theta. When I solve for my cosine of theta, I get negative 1/2. And I now ask myself, when is cosine negative 1/2? This is in the second and the third quadrant, and the reference angle is pi over 3. So my first answer, let me think about this for a minute, make sure I'm not messing up. And yes, that is right, pi over 3. Getting a little bit tired here. So in the second quadrant, that's 2 pi over 3. And in the third quadrant, that is 4 pi over 3. And these are now my two solutions. Alrighty, this brings me to number 14. Once again, I am going to have to bring over the tangent of theta to one of the two sides and the 3 cosine, bringing it over. You'll notice it cancels. And I'm looking at 0 equaling negative root 2 tangent of theta, cosine of theta, minus tangent of theta. I'm going to factor out the tangent of theta so that 0 equals tangent theta times negative root 2 cosine of theta minus 1. And you'll notice I can even factor out the negative if I wish. I'm going to go ahead and leave it in because I can now say, when is tangent of theta equal to 0? And we know that the tangent of theta is 0 at 0 pi and positive pi. I'm then going to take the negative root 2 cosine of theta minus 1. I'm going to set it equal to 0. Let's do it over here. And I'm going to have root 2 over 2 is equal to the cosine of theta. This is going to occur in the first and fourth quadrant. First and fourth, the reference angle is pi over 4, so I have pi over 4 and 11 pi over 4. These are now my 4 answers, and I would put it in a solution set and be done with it. Let me just double check. I need to go to the, oh, no, I got that right, okay. Now let me just double check, make sure I haven't done anything silly. Sometimes that happens, and I do not wish to have that. So I have my negative coming over, I factored out the tangent, I could have factored out the negative, that's giving me the first and fourth quadrant, and I believe those are my answers. I'm going to double check that. In fact, I'm going to go and do this because when I look at my answer key, it says that it is 3 pi over 4 and 5 pi over 4. And I want to make sure that I have it correct. So let's take a little bit more space. Let's go 4 let's see, what was that? Tangent of theta plus 3 cosine of theta equaling negative root 2 tangent theta cosine theta plus 3 cosine of theta. Okay, I'm going to subtract 3 cosine of theta. I end up getting tangent of theta equals negative root 2 tangent theta cosine theta. As these canceled, leaving me with 0. 0 equals negative root 2 tangent of theta cosine of theta minus tangent of theta. This time I'm going to avoid any issues by subtracting the negative tangent of theta. This leaves me with root 2 cosine of theta plus 1. I now have negative tangent of theta equaling 0. This once again is pi, 0 pi and pi. I have root 2 cosine of theta plus 1. There we go. There was my negative. Notice I just needed to do it on a separate piece of paper to find that negative. What happens when you get tired? You start making mistakes, so please be careful. My cosine of theta is therefore negative root 2 over 2. And now we are looking in the second and the third quadrant. It is once again a pi over 4 reference angle, and therefore 3 pi over 4 and 5 pi over 4. And then these are my solutions. This leaves me with the last problem on this. The last even problem is dealing with number 16. Number 16, once again, we have to simplify. Notice that the sign will cancel, and I'm going to move this cosecant over. And I have, therefore, 0 equals negative root 2 cosecant of theta, and I have a plus 2 cosecant of theta sine of theta. Factoring out the cosecant of theta, I get cosecant of theta times negative root 2 plus 2 sine theta. When is cosecant equal to 0? That's going to be my first question. Well, let's see. Cosecant of theta can never equal 0. Well, why? Because it's that parabola, remember? And it has that range that goes from 1 to positive infinity or negative 1 to negative infinity. Therefore, it's never going to happen. Cosine of theta cannot equal 0. No solution. This brings me to the second part, and right here I'm going to now solve this by adding root 2 and dividing by 2, and I get the sine of theta equals root 2 over 2. This occurs in the first and second quadrant. The reference angle is pi over 4, so we have pi over 4 and 3 pi over 4 as my solutions. And there it is. That is the worksheet that I have asked people to work on. That is more practice on solving trigonometric functions and trigonometric functions that are quadratic. I hope this has helped. Please remember to click like if you found this appropriate or useful. And if you have suggestions, please make sure you let me know. Thank you very much. Take care, be safe, and have a wonderful weekend. Cheers, Hornets. Bye-bye.